Okay, so we are on page 8, sine of x over x. Can we go graph that in a Zoom 6 window? And it should look pretty similar to mine. And when I say pretty similar to mine, is yours kind of looking like this? Is yours looking like that? To Beck's point, you hit the little hill, it doesn't go quite as high. My hill goes up to 1. What does your hill look like it's going up to? Love it. Okay, so what would we say the limit as x approaches 0 goes to? As x approaches 0, where do my lightsabers come together? At 1, right? So this one, the limit as x approaches 0 is 1. What if they change it to the sine of 4x over 4x? Let's go graph that guy. I'm going to leave my original one. Then I'm going to write the sine of 4x. And then I'm going to divide that by 4x. I'm going to graph that. Oops. I think I did that wrong. I need some parentheses around that. There we go. Mine is the, which one's that one? Mine's the red one now. Would you say as x approaches 0 that it still has that same limit? Yeah. So the sine of 4x over 4x is still 1. Do you see on mine, though? What's going on at 0? What's going on up here? What do you see? It's a hole. There's a hole there. Does it make sense? If I put 0 in here, can I divide by 0?
No.
It's undefined, right? So even though there's a hole, do my fingers still come together?
Yeah.
Yeah, so when my fingers, bless you, come together, that means that that limit exists. So anytime that angle matches the denominator, the limit's always going to be 1. Agapish? Okay, last one then. What about same graph as the original? So I'm going to go back and I'm going to take out the second graph. And this one, they just want to know what happens as x goes to infinity. That's the only difference between this and this. What do you think the limit is going to be as x goes to infinity? As I go infinitely to the right, where does it look like that y value is going to? Is going to 0, okay? So this one over here, that limit's going to be 0. These two, we need to have memorized. As we go infinitely to the right or to the left, that limit's going to be 0. As I approach 0, that limit's going to be 1. Okay, what if I'm asking about this guy, the tangent as x over x? Weird. I do have this beautiful pillow. Anything I could do with tangent to help myself? Yeah, couldn't I make tangent the same as sine over cosine? Tangerine equals sine over cosine. So you guys, how we could rewrite this? It's the limit as x approaches 0. Instead of tangent of x, I could say the sine of x over cosine of x. I just replaced that with this. And I can still put that over x. So I'm going to still say over x. Have I changed my problem? I have not. What if I plugged in a 0? Do I still have it undefined, though? Because I'm still dividing by 0. So let's go multiply by that reciprocal. The limit as x approaches 0, if I keep that sine of x divided by cosine of x, sine over cosine divided by x is the same as sine over cosine times the reciprocal. What's the reciprocal of x?
1 over x.
That's it. Thanks, Coop. You guys, question. What if I said, you don't have to write this out, 1/4 times 2/3? What would you say that is? 2 over 12, and we don't have to simplify it. Is that the same as 1/4 over 2/3 equals 1/4 times 2/3? Is that the same as 1/3 times 2/4? Yeah. Yeah, what did I do? Am I allowed to move these around? The 3 and the 4, I moved them, didn't I? And I can when I multiply. When you multiply across, it doesn't matter the order. So I bring that up because could I rewrite this in a way to help me? Check this out. Is this now the same, as, get out of here. Can I say, oh, that's the same as the sine of x over x times 1 over cosine? Did I change my problem? Is it still sine over x cosine, sine over x cosine? I just rearranged it. That's like saying, hey, everybody in first period, just take a new seat. Are we still in first period? Yeah. But I did that because do we know what this is? Do we know what that is? The limit as x approaches 0 of sine of x over x is just 1. I know this part is 1, and you might be saying, but it's being multiplied by that. I agree. Let me show you something. Let me get rid of this. We talked about these limits a little bit the other day, this limit and apply it to each of them. The limit as x approaches 0, sine of x over x, times the limit as x approaches 0 of 1 over cosine. We can kind of distribute that limit symbol. So, can we replace this limit as x approaches 0 of the sine of x? I can replace this whole ditty with 1, boom, times what happens when I plug in a 0 here? You know what I might do for y'all? Print you off a unit circle. Do you guys have a unit circle on you? From the summer work quiz, maybe? I'll print one off for you for some people that maybe just threw out their summer work quiz. If I plug in a 0 here, that's saying 1 over the cosine of 0. 1 over the cosine of 0. That's saying what is the x coordinate when I have 0 radians?
1.
It is 1. So when I plugged in, and you might want to draw yourself a little note, I plugged that 0 right in right there. Plug that 0 right in right there. I didn't plug it in right here because it would have been undefined. But per the graph, I know that rule, that this limit is 1. When I plug it in here, I'd get, oh, that original 1 times 1 over 1. Final answer?
1.
1. Let me back this up. Defining a limit as x approaches c. To make sure that a limit exists, here's some formal notation that I do want to make sure that we're comfortable with. It says the limit as x approaches c of a function equals some value L. Question, does anyone remember? I did tell you what this meant last year in pre-calc. What does IFF mean? If and only if. It's very redundant. The limit exists if and only if the limit as x approaches c from the left side of a function is one value, and the limit, I really didn't write this well, as x approaches c from the positive side of a function is the same value. On 1/6, let's go first. We did a little bit of this on 1/5. The first thing that you always do when we try to evaluate a limit is just plug it in. If I plug in a 0 here, what would I get if I plugged in a 0 to all of my x's? It'd be 0 over 0, and I really want to make sure you guys write that. That is 0 over 0. And I'm going to go ahead and do you a fave, and I'm going to go ahead and graph this for you. Negative 2x to the 4th. You don't even have to graph it. I'm going to do it for you because I love you. 4x cubed, and then 5x to the 4th, and then minus 9x to the 3rd. Boom. Where are we looking as x approaches 0, right? Based on this graph, you guys, we're looking at the limit as x approaches 0. Based on this graph, would you say my limit is going to exist? Do my fingers come together? Yeah. Do I know what it is at 0? No, it's undefined. And as you can see on mine, it's got a hole. If you guys did it, it's not going to show a hole. We'd have to do zoom 4 to show the hole. So how the heck am I going to find that approximate value without my calculator? Well, we got a hole. So what we've got to do is like some algebra to factor this hole out. On top, you're saying, oh, I've got stuff in common. Let's factor it out. I agree, Ritz. What do we want to factor out of the top, you guys? A 2x to the 3rd. Positive or negative? It doesn't matter. You want to take out a positive? And that's what you guys were going with, so let's leave it that way. I dig it. What would be left if I took out a positive 2x to the 3rd? Negative x, right? Plus 2, all right. What about the bottom? Anything in common there? X to the 3rd, what's left? Beautiful. Can I cancel anything out since I factored the stuff out? Yeah, don't the top and the bottom both have an x to the 3rd? So my limit as x approaches 0 when I factor that stuff out is 2 times negative x plus 2 over 5x minus 9. What happens when I plug that 0 in now that I've gotten rid of that common factor? What am I going to get on top? If I plug a 0 in there, I'm going to get -0 plus 2 gets me 2, times 2 gets me 4 over -9. Answer is -4/9. Does that look? -4/9. Does anyone remember what that is as a decimal? Ninths are the best. 1/9 is 0.111. 2/9 is 0.222. 3/9 is 0.333.
So
4/9
repeating.
is 0.444. -0.444. Does that look about like it's going to be -0.444? Yeah. So you guys, my answer, this does have a limit. If this was multiple choice, is AP going to say non-existent? They're going to have that as an option. But you got to be like, no, even though it's 0 over 0, I got to do some magic and factor some stuff out and get rid of that hole. What we just did is we got rid of the hole to see what was left. That's funky though. Let's try number 2. On number 2, when I plug in that 5, because sometimes you guys, when we plug in 5, we are going to get a value, and then that's the answer. If you get a number right away, you're done. That's the best. But on this one, what do we get? 25 minus 35 is -10 plus 10 is 0 over 0. When that happens, the answer is not necessarily doesn't exist. We've got to go factor. And on this, would we toot or o-toot? I.e., why I had you do some summer work. Would we toot or o-toot? Yeah. What multiplies to be 10 and adds to be -7? Multiplies to be 10, adds to be -7. He said -5 and -2. Amen. Okay, so do we have anything in common here? Hey, can we cross x minus 5 and x minus 5 out? Did I just get rid of the hole? I think so. So what happens when I plug in the x, as x approaches 5 of what's left? What happens when I plug that in there? 5 minus 2 gets me 3, Marek. Excellent. Okay, let's take a peek. So, Mar, you writing this stuff down or no, bud?
Oh, yeah.
You're going to want to get this done, buddy. Just hop in with us on number 3, okay? On number 3, when I plug in a 1, what do we get? Annoying. Can we factor?
Yeah.
That bottom one, what's that bottom one going to be? Difference of squares. What will that turn into? Awesome. Again, this is the stuff, you guys, why I had it on our summer work. We've got to be able to factor this stuff. Any common factors? You know it. What's left? Nice, thanks. Don't forget that that's 1 over that. That's huge. A lot of people are going to forget the 1 on top. Okay. What happens now when I plug in that 1? I get 1/2. Is that my limit? Sure is. Let's take a peek at 4. What do you think's going to happen when I plug that 2 in? Probably. Here we go. What are we going to get? We're getting 0. 4 minus 6 plus 2 is definitely going to be a 0 over 0. Now, how many people are like, dude, I'm annoyed at writing this limit notation? You do need to keep it going. Like, Meister is going to make you write it you just have to write it because it's not proper notation without it. Is it annoying? 100%. I validate that. Yeah. So annoying. Yeah. Okay. So you guys. Toot or o-toot that top? Toot. What multiplies to be 2 adds to be -3? That's okay. What multiplies to be 2? I think you had it. -2 and -1. Right, Ritz? Because multiplies to be +2, adds to be -3. I think you had it. Bottom. Very good. Factors into
2 minus 4, 2 plus 4.
close. Square root of 4?
2.
You got it. And is something going to have to cancel out? Like, use that as a little tip to yourself. Be like, okay, it's going to match on one of these probably. Any common factors? You know it. Now, at this point, biscuit, if you're like, dude, I don't want to rewrite all of this. I know that these are gone, so I'm just going to do this. I'm fine with that, biscuit. Yeah, I'm just writing it out nice and formal just so that people see it all, but you can take that shortcut. Faux shizzle. Here we go. What happens when I plug in 2 here? 1 over 4. I love it. We're on number 5. We're breezing. What happens if I plug in a 0 here? Annoying. 0 over 0. Whoa. Do I want to factor this one? What do I do with that? Couldn't I actually distribute it out? What's 4 plus x times 4 plus x going to get me? Let's think. Sometimes, you guys, if I were a you, I wasn't good at this unless I wrote it out. Some of you are. Do what you need to do. What is 4 plus x times 4 plus x?
X squared.
Oh, you going descending. I dig it.
Plus
Plus
8x.
8 x's.
Plus 16.
I love it. And then I'm going to bring down this minus 16. All over x.
Ooh,
Ooh, what happens, Mar?
why is there 2 negative 16?
Good question, because when I distribute that out, don't I get a 16 there? And then that minus 16 I just brought down. Yeah?
Forgot to do
Oh, thanks. Is that what you were asking?
Yeah.
Thanks, Mark. Sorry about that. Guys, is this helpful now? What happens when you get plus 16 minus 16? They gone. What does everything have in common now? An x. Can I go, you gone, you gone, you gone? Because I'm biscuit and I don't want to write the limit as x approaches 0 every time. Did I save myself a couple steps? I did. What am I really left with now once I cancel stuff out? Say that again. X plus 8 over 1, and I can just write that as x plus 8, right? What happens when I plug in 0 now? You just get 8. Yeah. Yeah, when we plug in 3, we're going to get 0 over 0. I want you guys to toot that, please. Top and difference of squares the bottom as I type this in. Multiplies to be negative 21, adds to be 4. What did you all get for that?
7 minus 3.
Plus 7 minus 3. I agree. How do you difference the squares the bottom? Be careful because I switched the order on you. Yeah. 3 has to go first. 3 minus x, 3 plus x. And then you're like, wait, I want to cancel something out. But do these cancel? Are these the exact same thing?
No.
They're not, right? Isn't this a negative 3 and that's a positive 3? And then that's a positive x and that's a negative x. So we can't cancel them. Could I do something to change one of them? Could I say, I'm going to just look at that bottom one. If I want it to match and I want that bottom one to be an x minus 3, what if I put a negative right here? What if I put a negative right here? Is this still negative x?
Yeah.
Is this still positive 3? Yeah, so by factoring this x out, does this now match that one? I'm allowed to do that because I didn't change my problem. If I distribute that back in, I get what I started with down there. So that's just a little skill that we've got to just get a little bit more familiar with. So I still have an x plus 7 and x minus 3 on top. And I changed this guy, but I didn't really change it. I just manipulated it so it would cross out. You cool with that, Koopy?
Yeah.
Okay. Can I now cross out my x minus 3? Am I left with an extra negative out front? Sure am. So I'm going to write that. That we got the limit as x approaches 3 of x plus 7 over a negative 3 plus x. If I plug that 3 in now for my x, did I mess up, bud? When I plug this 3 in now, what do I get on top? 10 over negative 6. Final answer, what could we simplify that to be? Negative 5/3. Let's look at my key. Here we go, number 7. This one looks disgusting.
Oh, yeah.
Oh, yeah. Negative 8 over negative 8 plus 6. What would that simplify to be when I've plugged that guy in? Negative 8 over negative 2 would be 4. What's 4 minus 4?
0.
0 over annoying. On this one, can I factor anything?
No.
Nah. And, okay, we can't factor this. What do you think I could do to just, like, combine those two? What do we need? We need common denominators. Like, oh my gosh, all this stuff we did in Algebra 1 and Pre-Calc and Algebra 2 is coming back to haunt me? Yeah, it sure is. What are we going to multiply that negative 4 by?
X plus 6.
Yeah, over x plus 6, right? To get a common denominator. 4's denominator right now is a 1. Okay, so as we do that, again, Biscuit's so sad because we have to write the limit as x approaches -8. I'm going to leave the first part, x over x plus 6, minus 4 times x plus 6 over x plus 6. All that is over x plus 8. I tried to give you guys extra room on this one because it's long. Let's go distribute that top. Let's go bring those common denominators around to help us. X approaches -8. We have x over x plus 6. Then what we want, and maybe, are you good if we just do one big, put that x minus 6 together? What would we get when we distribute this? Careful with that negative. You got it. Minus 4x minus 24. Is that right? Okay, just a heads up. You might be like, I just want to plug in -8 now. That's going to get me -8 plus 32, which is 24 minus 24. Oops, I wrote that bottom wrong. It's going to be x plus 8. We're still going to get 0 over 0 because we haven't crossed anything out yet. So we still got to keep simplifying. Anything can't simplify here? What's x minus 4x? Thanks. So we got, all right, the limit as x approaches -8 of -3x minus 24. If I plug in a -8 right now, I'm still getting 0 over 0. Could I factor anything out of that top? Yeah, let's take a -3 out, you guys. If I take out a -3, that's left.
X plus 8.
Hey, is that helpful?
Yeah.
What's on the bottom?
X plus 8.
Psh! What's that limit gonna be? Did I forget something along the way, you guys? What a goober. So you're saying, hold up. What, you're saying this whole thing needs to be over an x plus 6? Is that right? This needs to be an over an x plus 6? Oh, man. It's okay. Mar. It's okay. You're going to go like this. Or, let's just do this. What are we going to be left? Oh, gosh. This is a hodgepodge. Oh, golly. Oh, geez. Yeah. Do you agree this was over an x plus 6?
Yeah.
So if I were you, so sorry, first of all, you could hop in here and you say, I've got -3 times x plus 8 over an x plus 6. Instead of dividing by an x plus 8, right? This x plus 8, instead of dividing by that, dividing by an x plus 8 is the same as multiplying by 1 over x plus 8. So I'm going to say times 1 over x plus 8. I'm sorry, guys. I really flubbed. Do these x plus 8s cancel?
Yeah.
They do because we're multiplying between these fractions. Anytime we're multiplying, top and bottom can cancel out. Push, push. And I'm left with, Biscuit doesn't want to rewrite it again, so Biscuit's going to do that, and he's going to plug in a -8. I'm going to rewrite it just because I want to be clear. I obviously wasn't clear before. My bad. And we're left with -3 over x plus 6.
Yep.
Can I plug it in now?
Yes.
And I'd get -3 over -2. Final answer? 3 halves. Unit circle, what's the tangent at 0 radians? What's the y over x at 0 radians?
0.
Yeah, it'd be 0 over 1, which is 0. 0 plus 0 over 0, oh gosh. Can this separate into the tangent of x over x plus the limit as x approaches 0 of 5x over x? Can we say, oh, this plus that and separate them out? We sure can. When you separate those out, can I say 5x over 1x is just going to get me 5? Yeah. Can we manipulate this using that talent, that rule that we had to memorize?
Yeah.
Instead of writing tangent, we could say, and I'm just going to work through it again. You might have this one memorized, good for you. But if you didn't, I think it's some good practice. Tangent's the same as what over what? Sine over cosine. Dividing by x is the same thing as multiplying by? Yeah. So dividing by x is the same as multiplying by 1 over x. Because I'm Biscuit, I don't want to rewrite this again. And Biscuit, I'm just picking on you, okay? Just because you said it once, I'm just going to go with it. I don't have to rewrite all this again because the limit as x approaches 0 is just 5. So I'm going to just say plus 5 there. Because those x's canceled out, I'm just left with 5 and I'm done with that limit. Phew! How can I rewrite this to help me?
1.
Yeah, well, I got to rewrite it just to make sure that it makes sense, right? So the limit as x approaches 0, I can rewrite sine of x over x, knowing that that limit's 1, and then I'd be left with 1 over cosine. I just moved these things around. When I multiply across, I still get what I started with, so I feel good about it. Bless you. And then I know this quantity is 1. And when I plug in that 0 here, cosine at 0, the x-coordinate at 0 radians is 1. So I'd get 1 over 1. Plus my 5, final answer. 6. People, AP question from 1998, the year that I got bangs. It's bad. See how big this forehead is? Not big, correct? Is there room for bangs here? It's terrible. It's terrible. As x approaches 2. You guys, for a limit to exist, as x approaches 2, don't I have to get the limit from the left of 2 and from the right of 2? Don't they have to equal for that limit to exist? How am I going to evaluate that here? So what I would do is I'm going to say, all right, the limit as x approaches 2 from the negative side. Which one of these functions would I want to look at if I'm approaching 2 from the negative side? Top one or the bottom one? Who said first and how'd you know? Yeah, how'd you know?
Because x is less than 2 in the first one.
Exactly. And if I'm less than 2, if 2's on a number line, everything to the left is going to be less than it. So I'm going to use that ln of x right there. I agree. When I plug that 2 in, because that's just what we do, y'all. What'd you get? And we don't have to simplify it. What would you get when you plug in a 2?
ln 2.
That's it. Thanks, Coop. Then we just got to think, all right, what happens as I approach 2 from the positive side? Which function would I use?
X squared.
Yeah, because I'd have x is greater than 2. That means I'm coming into x from the positive side. I'd have x squared ln of 2. What happens when I plug my 2 in there? Yeah.
Consistent.
How'd you know?
Good. Because they're not equal to each
Yeah,
other.
from the left and from the right. If the limit existed, these two things would have to be equal. Oops, I didn't write ln of 2. And because they're not, you're going to say, This one without a calc. What? 2014. Here's how we do this without a calc. You got to think, and maybe just, you could even give yourself a picture if you care. Again, you wouldn't be able to do that without a calculator, but we were at 1, -1 there. Just in case you were curious. Okay, without a calc, what's a number just to the left of 3? Really close to 3. As x approaches 3 from the negative side, gets really close.
2.9.
I like that. Positive or negative?
Positive.
Yeah, my bad. I don't know why I asked that. Okay, 2.9, right? You guys, what happens if I plug in a 2.9 there? 2.9 minus 3 over 2.9 minus 3. On top, what's 2.9 minus 3?
-0.1.
-0.1 absolute valued, Mar, is 0.1. Mar, what about 2.9 minus 3 on the bottom? What's any number over itself? What's 8 divided by 8? What's 8 divided by -8? So what's 0.1 divided by -0.1?
-1.
Yeah, any number over itself is just 1. The negative is just going to stay. You're like, what if I wouldn't have chosen 2.9? What if I would have chosen 2? I'm like, okay, well, let's try a 2. And you don't have to write this down if you don't want, you guys. But if you just did 2, would that give me the same answer? What's 2 minus 3? -1. Absolute valued is 1. 2 minus 3? negative 1, is that still negative 1?
So they probably wouldn't do this.
Population, it is known that the limit as x approaches 0 of sine of 2x over 2x equals, we just know this. It's just 1. What is what? Now they say, okay, since you know that, let's go get this. You're like, okay, dear. How can we rewrite tangent of 2x? Perfect. Don't change that angle. That's great. So he says, okay, I still know that tangent is just sine over cosine. I'm going to leave those angles. Sine of 2x over cosine of 2x. Guys, instead of writing a huge fraction, actually, no, I am going to do another big fraction because that secant's ugly. How could I rewrite secant?
1 over
1 over cosine. So could I actually rewrite this as 6x over cosine of 3x? Could I do that?
Yeah.
Okay, I'm doing that because I know dividing by a fraction is the same as multiplying by the reciprocal. So it helps me to see that as a fraction. So I'm going to say, biscuits hating me, limit as x approaches 0. I'm going to leave that sine of 2x over cosine of 2x. Because right now, you guys, I apologize. I kind of skipped a step. If you plugged in a 0 here, y'all were getting 0 over 0. That's why we got to go take these steps. When we say black divided by red, that's the same as black times red's reciprocal. The reciprocal is going to be the cosine of 3x over 6x. Can I go like this? You're right, Lob. Here's my problem. My angles don't match, so I don't get to cross them out. That's annoying. That's annoying. I don't get to cross them out. But you guys, do you agree? Check this out. Could we say the limit as x approaches 0? Do you agree that the sine of 2x over 2x is 1? We know that right there. We just said that. Now, I used this sine of 2x right here. Is 2x times 3, if I just threw a 3 down here, still the same as a 6x? Can I just break this 6x apart and say, all right, I need 2x, but I still need to multiply that by 3 to get what I started with? Yeah, am I going to expect you to do that on day 1? No, I'm just trying to show you some new techniques. I'm taking this 6x, I'm putting it under my sine of 2x, but I'm just breaking it apart a little bit. So I've got that 3 still down here. And then I still have a cosine of 2x on the bottom and a cosine of 3x on the top. That was a lot, what I just did there. That was a lot. Do I still have everything accounted for, though? Cosine of 3x is still up top, cosine of 2x is still on the bottom, and 6x is still on the bottom, 2x times 3. Can I now say, oh, I know what this is. What's this part going to be? 1 times, you guys, that 0 now, I got to go plug it in for my x's. What's the cosine at 0? The x-coordinate at 0 radians is 1 over 3 times cosine at 0 again is a 1. Whoa. What happens if I plug in a 3 here? 0 over 0. Can we simplify or factor out anything from the top? Nah, what about that bottom? What's in common in that bottom? Take an x out. What's left?
X squared minus 3, or 9.
Very good. If I plugged in that 3 still, I'm going to get 0 over 0 because nothing canceled out. Can we do anything with this? Difference of squares it, people. So I've got limit as x approaches 3, x minus 3 on top, x times, what's that difference of squares looking like? X minus 3x plus 3. Anything cancel now?
Yeah, it's minus 3.
Yeah, what's on top? Be careful, be careful, be careful.
1.
Yeah, don't forget that 1. Thanks, Coop. Over x times x plus 3.
Which would be x squared plus 3x.
True, and you could do that if you want. Regardless, we got to go throw a 3 in there. That's going to get me 3 times 6 on the bottom. Final answer,
118.
perfect.